Among all the concepts we use daily, few seem as familiar and yet as puzzling as space and time. We cannot point directly to either of them, yet everything appears within their embrace. Every object occupies some space, every event unfolds in some temporal interval, and every action seems to rely upon the steady background of both. We move through space, we age through time, and we organize our lives by the rhythms they impose. Despite this intimate presence, space and time refuse to show themselves plainly. They are not objects we encounter, but conditions that make encounters possible. They structure the world invisibly, like the stage on which all existence plays out. Philosophers, scientists, and poets alike have wrestled with these strange dimensions for centuries. We speak of time flowing, yet we cannot hold or measure a flow except through the change in things. We speak of space stretching out before us, yet we never see space itself or objects placed within it. These paradoxes have inspired some of the deepest metaphysical debates. What exactly are space and time? Are they things that exist independently, or are they merely relations between objects? Do they have an absolute nature, or do they depend on the arrangement of matter and energy? Are past and future real, or is only the present real? Does time pass, or do we only experience change in such a way that it feels as if time passes? These questions lead us into the philosophical heart of how reality is structured. This lecture explores the metaphysics of space and time, not in the technical language of physics, but in the broader, reflective language of philosophy. We will look at how thinkers from antiquity to today have tried to understand the strange nature of these two universal frameworks of existence. We will see how disagreements about space and time quickly become disagreements about the structure of the world itself. And we will discover that our own everyday intuitions often hide metaphysical commitments we rarely question. Long before modern science, human beings wondered about the nature of space and time. In their earliest forms, these reflections were tied to ancient cosmologies and religious narratives. Nonetheless, even without telescopes or clocks, ancient thinkers identified many of the questions that continue to animate metaphysical inquiry today. Some Presocratic philosophers imagined space as an infinite void, a kind of unbounded container in which all things move. Leucippus and Democritus, the early atomists, described the universe as composed of indivisible atoms moving in the canon, the empty void. Others thought that space is not truly empty. Anaximenes held that cosmos is filled with air as a subtle underlying substance, while Heraclitus conceived reality as an ever-living fire. Time too was mysterious. Many thinkers, such as Empedocles, understood time cyclically, reflecting the recurring rhythms of nature and agriculture. Others, especially in emerging religious cosmologies, saw it as linear, stretching from a primal origin toward a future culmination. Although these early reflections remain speculative, they show that the puzzle of space and time has always accompanied philosophical thought. The fact that everything happens somewhere and sometime invites us to ask what kind of reality these frameworks possess. With the rise of modern science in the 17th century, questions about space and time took on new urgency. Isaac Newton, perhaps the most influential scientist of all time, provided a powerful and enduring vision of both. Newton believed that space and time are absolute. Space, he argued, is an infinite container that exists independently of the objects within it. Time is an endless sequence of moments, flowing uniformly and unaffected by the events that take place. To understand the idea of absolute space, imagine an empty universe containing no objects whatsoever. According to Newton, space would still exist. Even without stars, planets, or people, there would still be an infinite grid of locations. objects, when they do exist, simply occupy regions of space. Space, in this sense, is like a vast, indifferent stage ready for any performance that might unfold upon it. It does not change, react, or evolve. It simply exists. Time, for Newton, has a similar absolute nature. It passes uniformly regardless of what happens. Even if the universe were to freeze, with no motion or change, time would continue to flow. In Newton's famous phrase, time flows equably without relation to anything external. This means that time has its own independent existence. It is not derived from events, but provides a framework in which events occur. Newton used these ideas to explain motion. According to his view, an object in motion follows a straight path through absolute space unless acted upon by an external force. Acceleration, not velocity, indicates a change. One of Newton's most famous arguments appeals to the example of a rotating bucket of water. When the bucket is spun, the surface of the water becomes concave. Newton argued that this concavity reflects the water's motion relative to absolute space. This example, known as the bucket argument, was meant to show that absolute motion and absolute rest make sense only if space itself has real existence. Newton's conception of space and time shaped scientific thought for centuries. It provided a clear mathematical structure that allowed for precise predictions and stable laws. Yet it also raised difficult metaphysical questions. If space and time exist independently of everything else, what kind of entities are they? What does it mean for space to exist when empty, or for time to flow when nothing changes? These questions troubled many philosophers who sought alternatives. One of Newton's greatest philosophical opponents was Gottfried Wilhelm Leibniz, a German polymath who believed that Newton's absolute space and time introduced unnecessary metaphysical mysteries. For Leibniz, space and time are not independent entities, but systems of relations. According to him, space is simply the set of spatial relations between objects. If no objects exist, no spatial relations exist. Thus, there is no space. Similarly, time is the order of events. If nothing changes, time does not pass. Leibniz rejected the idea of absolute space because it seemed to multiply entities beyond necessity. He argued that absolute space leads to absurd consequences. For instance, imagine two universes that are identical in every respect, except that one is shifted 5 meters to the east. According to Newton's view, these two universes would be different because objects occupy different places in absolute space. According to Leibniz, they would be identical. He believed that differences without observable consequences are meaningless. If no measurement or experience could ever distinguish the two universes, they should not be regarded as distinct. Leibniz also appealed to theological considerations. If absolute space exists, he claimed, then there is no reason for God to place the universe here rather than there. This seems to violate the principle of sufficient reason, the idea that everything must have a reason for being the way it is rather than differently. By rejecting absolute space, Leibniz sought to preserve a rational and elegant universe. In relational view, space and time emerge from the arrangement of things rather than existing as independent containers. Space is the order of coexistences. Time is the order of successions. Without objects, there is no space. Without events, there is no time. This relational ontology challenges the Newtonian picture and continues to influence philosophical and scientific thinking. The debate between Newton and Leibniz continued for centuries, but a major shift occurred with the work of Ernst Mach in the 19th century. Mach proposed that the inertia of objects, which Newton had connected to absolute space, actually depends on their relation to all other masses in the universe. In other words, the behavior of a spinning bucket depends not on its relation to absolute space, but on its relation to the distant stars. Mach's idea influenced Albert Einstein profoundly. Einstein saw in Mach's relational critique a way to reformulate the foundations of physics. Although Einstein's final theory of relativity did not fully implement Mach's principles, it transformed the understanding of space and time in ways that undermined Newton's absolutism. Space and time, Einstein argued, are not independent entities, but aspects of a unified space-time that interacts with matter and energy. The 20th century brought a revolution in the understanding of space and time. According to Einstein's theory of relativity, they are not separate. They belong to a four-dimensional continuum known as spacetime, often described mathematically as a spacetime manifold. A manifold is a kind of geometric space that may be curved or flat, and that can vary from place to place. In everyday terms, a spacetime manifold is the structured fabric within which all physical events occur. It is the arena of the universe, but unlike Newton's absolute space, this arena is dynamic. In this view, the geometry of spacetime is not fixed. It curves and stretches in response to the distribution of mass and energy. Measurements of time and space depend on the observer's motion. Clocks run at different rates depending on speed and gravitational field. Space contracts or expands depending on motion. These effects are not illusions. They are features of reality. This raises deep metaphysical questions. If space-time is dynamic, does it exist independently of matter? Or is it a relational structure that depends on physical interactions? Einstein resisted simplistic interpretations. He believed that space-time is real, but its reality is not that of a static container. It is more like a fabric woven by physical processes. Moreover, relativity challenges common intuitions about time. According to the theory, all of spacetime exists equally. These past, present, and future are all part of the spacetime manifold. This seems to imply that the flow of time is not an objective feature of the universe, but a feature of human experience. This leads us to the metaphysics of temporal existence. One of the central metaphysical debates about time concerns whether all times exist equally or whether only the present is real. The first view is called eternalism, defended by many analytic philosophers, including J.J.C. Smart, D.H. Miller, and Hugh Price. According to eternalism, past, present, and future events all exist in the same way that different locations in space exist. Just as Paris and Tokyo exist even if you are not in them, the year 1200 and the year 2200 may both exist even if you are not located in those times. The opposing view is presentism, defended by philosophers such as A.N. Pryor, Trenton Merricks, and Dean Zimmerman. According to presentism, only the present is real. The past no longer exists. The future does not yet exist. Our everyday language reflects this intuition. This no longer exists. This does not exist yet. Between these extremes lies the growing block theory, associated with thinkers such as C.D. Broad and more recently Michael Tooley. According to this view, the past and present exist, but the future does not. Reality grows as time passes. Each new moment becomes part of the fixed past once it occurs. These positions raise profound questions. If only the present exists, what becomes of truths about the past? If the past exists, in what sense does it exist? If the future already exists, what happens to free will? Ordinary language suggests presentism. but modern physics leans toward eternalism. The debate is far from settled. Another major metaphysical question concerns the passage of time. We feel strongly that time flows, that the present moves forward, that moments pass from future to present to past. But does time itself pass? Or do we only experience change in a way that gives rise to this impression? The English philosopher J.M.E. MacTaggart famously argued that time is unreal. He distinguished between two ways of ordering events. The first, which he called the A-series, orders events as past, present, or future. The second, the B-series, orders events as earlier or later. MacTaggart argued that the A-series is essential to time, but it leads to contradictions. Therefore, time cannot exist. Few philosophers accept MacTaggart's conclusion, but this distinction between the A-series and the B-series has shaped metaphysical debates. The A-series corresponds to the tensed view of time, in which past, present and future are objectively different. The B-series corresponds to the tenseless view of time, in which all events simply have fixed positions in the temporal order. Many argue that the flow of time is an illusion created by consciousness. On this view, time does not move. Events do not slide from future to present or past. Instead, consciousness experiences different moments sequentially, giving the appearance of flow. This view may seem counterintuitive, but modern physics lends it some support. Others, such as George Ellis, Tim Maudlin, and C.D. Broad, insist that time genuinely passes. They argue that the flow of time is a basic feature of reality, irreducible to physical or psychological processes. This ongoing debate reveals the difficulty of reconciling intuition with scientific theory. Philosophical reflection on time cannot ignore the role of experience. Human beings live in time not merely as a physical dimension, but as a psychological and emotional one. We experience duration, anticipation, memory, boredom, waiting, and urgency. These temporal emotions shape our lives. They reflect not only physical processes, but also our personal history, expectations, and desires. The French philosopher Henri Bergson emphasized the qualitative nature of time, which he called duration. He argued that real time is lived, not measured. Clocks, he said, capture only the spatialized representation of time, not its inner essence. For Bergson, time is experienced as a continuous flow of consciousness, where past and present interpenetrate. Modern cognitive science has provided further insight into the psychology of time. Our perception of duration can speed up or slow down depending on motion, emotion, and novelty. Time seems to crawl during moments of fear and rush during moments of joy. These experiences remind us that time is not merely an external parameter, but a structure of consciousness. Yet the psychological experience of time raises metaphysical questions. If the flow of time is a feature of consciousness, not of the world, then what is the true nature of temporal reality? Does the universe contain a privileged present moment, or is the present simply the point at which consciousness encounters the world? These questions bring metaphysics and phenomenology together in a complex dialogue. Much like time, space invites competing metaphysical interpretations. Is space a thing in its own right, or simply a network of relations among objects? Newton's absolute space treats space as a kind of substance, though not a material one. It exists independently of objects. Leibniz's relational view treats space as a system of relations. If objects disappear, space disappears. Modern debates have become more sophisticated, but still revolve around similar questions. Some philosophers argue for substantivalism, the view that spacetime is an entity that exists independently of matter. Substantivalism is supported by the role spacetime plays in general relativity. Spacetime curves, stretches, and interacts with matter. These behaviors seem to suggest that spacetime has real physical properties. Others favor relationalism. They argue that spacetime does not exist independently, but depends on the relations between physical objects. According to this view, spacetime is a useful mathematical tool, not a fundamental entity. Relationalists often appeal to philosophical principles of economy or to concerns about overpopulating our ontology with unnecessary entities. Between these views lie intermediary theories. Some hold that spacetime is emergent, arising from deeper physical processes. Others propose that spacetime may not exist at the most fundamental level, and that the universe may be structured by non-spatial, non-temporal relationships, such as those found in quantum gravity or string theory. These debates show that even with the advancements of modern physics, the metaphysics of space remains open. Space is not merely a background, but a contested concept. Space is often associated with the three-dimensional geometry we learn in school. Yet modern science suggests that space may have a much more intricate structure. Einstein's theory of general relativity reveals the space is curved by mass and energy. This curvature is not just a metaphor. It affects the motion of objects and the path of light. This raises metaphysical questions. If space has geometry, what determines that geometry? Is it intrinsic to space or imposed by physical fields? Does space have a shape? Could the universe be finite yet unbounded like the surface of the sphere? If so, would that make space a kind of three-dimensional analog of a curved surface? Such possibilities challenge our intuitions. Philosophers have long considered whether the geometry of space is an empirical fact or a necessary truth. Immanuel Kant believed that Euclidean geometry was built into the structure of human cognition. Modern science overturned this idea by showing that Euclidean geometry is not the only possible geometries, and that physical universe appears to be non-Euclidean on large scales. The nature of spatial geometry illustrates how deeply metaphysics and physics intertwine. The structure of space is not merely a matter for physicists. It raises philosophical questions about necessity, possibility, perception, and the relation between mind and world. Another puzzling aspect of time is its apparent direction. We cannot change the past, but can influence the future. We remember yesterday, but not tomorrow. Ice melts, but never spontaneously reassembles. Coffee cools, but it never spontaneously heats. These asymmetries suggest that time has a direction, often called the arrow of time. Yet the fundamental laws of physics are time-symmetric. They do not distinguish between past and future. According to these laws, a film of a system evolving forward in time could be played backwards without violating the equations. This leads to a metaphysical puzzle. If the laws of nature do not contain an arrow of time, why does the world we experience seem so asymmetrical? One common explanation appeals to entropy, the measure of disorder. The second law of thermodynamics states that entropy tends to increase over time. Some philosophers argue that the arrow of time arises from this statistical tendency. The universe began in a state of extremely low entropy, and everything since then has been a movement toward higher entropy. This explains why we remember the past and not the future. Memory formation requires irreversible processes. Yet this explanation merely shifts the question. Why did the universe begin in a low entropy state? Is this an accident, a necessity, or the result of some deeper principle? These questions lie at the boundary between physics and metaphysics, and they illustrate how time remains one of the most mysterious aspects of reality. Philosophical questions about space and time are not purely theoretical. They shape the way we understand human existence. Our sense of self is tied to memory and anticipation. We inhabit the present moment, but our identity stretches across time. We imagine possible futures and interpret our lives as narratives. All of these depend on the nature of time. Space too affects our sense of self. Our bodies occupy space and have boundaries. Our relationships are shaped by physical proximity and distance. Our social and cultural worlds depend on the spatial organization of societies. Even our metaphors reflect spatial thinking. We speak of moving forward in life, of horizons of possibility, of feeling close to someone. These spatial metaphors reveal how deeply space shapes our understanding of existence. When we question the metaphysics of space and time, we are therefore questioning the frameworks that structure human life. We are asking what it means to be embodied, to remember, to anticipate, to act, and to exist. As we move forward in these metaphysics lectures, the insights gained from space and time will prepare us for deeper questions. The next lecture will focus on identity and persistence, examining how things remain themselves through change. The metaphysics of time will play a crucial role in that discussion, for identity is always identity through time. The metaphysics of space will also return when we consider objects, properties, and structures. Space and time form the stage of reality, but they are not passive backgrounds. They shape and are shaped by the world. They invite us to reflect on the deepest aspects of existence. By examining them closely, we begin to see how rich, complex, and mysterious reality truly is.